philosophy graduate school. I did finish my PhD, but I wasn't finding the sort of work that I wanted after that was done. It's very difficult in academia to get the sort of high-powered job that a lot of people are looking for. And I moved to Seattle, and after I got to Seattle, I decided that I wanted to go back to school. And I did have an old physics degree rusting on my shelf somewhere, so I thought, well, I've got some math skills. I think I could go do this applied mathematics program at the University of Washington. And shortly after I started that, an old friend of mine from philosophy grad school, Mike, said, "Hey, have you studied any R?" And I started looking into it, and I thought, wow, this R language looks really cool. I don't have a lot of programming background. I've done a little bit here and there. But I started looking into R. I took a course on R. I realized sort of immediately its potential for data analysis and data science. And that was sort of my entry in. I started reading a bunch of things about data science. I jumped into a boot camp for data science. And before long, I had finished a boot camp and I was able to land a job teaching at Flatiron School in data science. And so that was sort of my entry into the tech world. It's never too late to start. It's never too late to jump into tech. I think, I think sometimes people are scared to make that transition. And obviously I meet a lot of people teaching a boot camp in data science who are scared. They're making these large career changes. They've been doing one thing and they're thinking, well, data science seems like something I could do. Maybe my background is quite different, and I'm scared to do it, but I feel like I've got a chance. And they really do. There's a lot you can learn in a short time. There are lots of resources about R, lots of resources about Python. Python is actually the language of choice at Flatiron, so I work mostly in Python these days. But it's one step at a time. There's always a lot to learn. But you don't have to learn a lot to be able to make some cool things, to be able to start on some cool projects. And once you can do that, well, then you can get in touch with other people who are working on things. You can share ideas. You can share your own work, and then you're sort of right there in the community. I think data science has arisen largely because of lots of technological improvements to do with data. So we are now incredibly good at storing data, at producing data, at having accurate data recordings. You can look online and find stats about exactly how much data is produced every day. I think it's, on the order of, quintillions of bytes or something like that, just huge amounts of data. And lots of companies have their own data these days to worry about. Amazon, for example, part of the reason that Amazon is successful is they have lots and lots and lots of data about their customers, about things that they've bought, about other things that they've bought, about, here's a bunch of things that people just like you have bought. Maybe you're interested in that too, And if you have access to a bunch of data about your customers and you can access it quickly, then that sort of proves its business value pretty quickly. So I think of data science as having a sort of immediate business angle, but there's also this kind of technological aspect to it. It's just as all of these technologies have gotten better, it's natural that we have a lot of data. We have to have some understanding of how we can store that data, how we can access it, how we can share it, all that stuff. So data science itself as a discipline, certainly it helps to have some understanding of things like databases and where data lives and how to access it and so on. But it's also a bit of coding, it's a bit of mathematics, it's a bit of statistics. And so, when we do our boot camps, we try to cover all those bases at least a little bit. Oh, I think they can. You don't need sort of entire college courses in that. You need some understanding of the fundamentals of data science. So you need to be able to understand simple things like if I know that my data are likely to be normally distributed, for example, that can be a helpful thing to know, right? Or maybe I'm drawing data from some binary distribution, and so I have some understanding of what that distribution looks like. You don't need sort of high-powered mathematical understanding, really. Just some basic understanding of statistics 101. There's a little bit of calculus that could help you, but not, that's not a huge aspect of it. There's a little bit of algebra that's helpful, but there are lots and lots of resources, I think, and the mathematics itself shouldn't be a hurdle, I think, for anyone who wants to study data science.
So what I want to know about data science is that data science is a separate discipline on its own right, right? And you're talking about using data to get some results, get some meaningful results out of the data. So,
Mm-hmm.
if, for instance, you're a university and you have data about the students themselves, the courses that they register for, how frequently they do it, in which semester, which course is more popular. If you wanted to say, I want to predict next fall, what are the courses that might actually exceed capacity, or I may need to have an extra teacher to teach this course because there's so much demand, but I need to know ahead of time so I could schedule it. That kind of a thing, right? So your
Yep.
data goes into some kind of a data warehouse where it's stored in some kind of structure, maybe tables that are probably not normalized. Would mean I would expect them to be lots and lots of columns, everything in there, so you don't have to do lots of joins because that's
Right.
faster to read, and then you would be able to actually ask your system some intelligent questions and it answers it. That's one aspect that I can think of. The other one is,
Mm-hmm.
hey, Mr. Data Scientist, I have these 100 terabytes of data. Go give me some insights. I don't know what I'm
Yeah.
looking for.
Yeah.
Which way is it falling here? This data science, is it both things?
Yeah, I think it's both things. I think very often, I think about data science very often as trying to solve problems with data, you know,
Mm.
and those problems can take lots of forms. Often sometimes they're just straightforwardly financial things like how can our business make more money, you know,
Mm-hmm.
um, and sometimes they're really more investigative things like, I've got a bunch of customers and I want to do some sort of customer segmentation because I want to,
Mm.
have a sort of targeted marketing campaign. I want, some ads to go to some people who are likely to pay attention to those ads and other ads to go to other people who are likelier to pay attention to that sort of advertising, you know. So there are lots of different problems. Um, but very often what's happening is the data scientists will build some sort of model, some sort of predictor. And you're right, very often the data that you start with has some sort of tabular form, right? Maybe I've got a bunch of columns of data and a bunch of rows. Rows will represent one record, one observation, one customer maybe, or one house up for sale maybe. And, each of the columns will be some feature about each of those records, so if I've got a bunch of houses for sale, maybe I've got a column that represents number of bedrooms. Or if each of my rows is, students at a college, then maybe one of my columns is, grades for a particular quarter or something like that. So um, the general idea is I've got all these columns, and one of my columns is sort of privileged. One of my columns is the thing that I'm trying to predict, the thing that I'm trying to model, right? And I'm going to use all my other columns, all the information that I have there, to try to make accurate predictions about what's in the column of interest. Um, if I've got thousands of rows or millions of rows, then it's very difficult for a human being to sort of, pick up on the patterns that might be there. But a computer is really fast, right? If I just show a computer well, here are the values that I get for these rows in these particular columns. And here are the values that I get for the column of interest. And then I say, okay, now here are some rows that you haven't seen before. And they have these values in these columns. What do you think it's likely to have in the column of interest? You know, and the computer sort of builds a model and then is able to use that model to make predictions on the unseen data that is new. And then you can sort of evaluate that model. Is it good? Is it accurate? And so on. That sort of thing is very often what's at the heart of a lot of data science problems.
Okay. So if I have to build that model, so some piece of software has to do that. So are
Mm-hmm.
you, as a data scientist, are you writing custom code? Is just start from scratch and just start building a model? Or do you use a tool and maybe script it a little bit?
There are lots of tools. I think really Python is probably the number one language right now for data science. And much of the reason for that has to do with the fact that there are lots of, well, first of all, it's open source. So it's an open source project, lots of people contributing. Um, and there are lots of tools, lots of libraries that you can just import into your own workspace that already do lots of really cool data science things, right? So if I want to build a random forest model, well, there are random forest tools that I can just import right into my own workspace, introduce them to my own particular data, and they'll build predictions for me, straight out of the box. And I don't have to sort of create the model from scratch. And so because of all these different libraries that are available in Python, really powerful, flexible tool, and you can get models up and running with really just a few lines of code because of all the work that's already
Mm.
been done by the library.
Yeah, that's great. Yeah, Python is a great language for
Yeah,
beginners, but also for people who are doing data science. But I wonder
yeah.
why Python, because I don't know what Python is doing that is so different than, say, Ruby or Java. There must be something. Maybe there's some built-in libraries that do certain things. I'm assuming some math functions that others don't.
Yeah, I think that's right. So, for example, there are certain libraries of Python that we introduce to our students in the first week because they will use them all the time. So, for example, there's a package called NumPy, numerical Python, right? And it's basically a tool for scientific computing. It's a tool for doing, sophisticated mathematics, but it's really fast, right? You can do sort of these vectorized operations. You can add arrays together lightning quick. You can multiply them. You can do, if you want to, you can do scientific notation. If you want to, you can do complex numbers. You can do trigonometry. You can do all sorts of stuff. Another tool is Pandas, and Pandas is the name I think comes from something like panel data, and it used to be this sort of object type called a panel. It's not really used much anymore, but anyway, um, really powerful tool for manipulating tables of data. The sort of technical term in Pandas is a data frame. A data frame is basically just a big table of data, and lots of really powerful tools for manipulating them quickly. Adding columns is, just a line. Multiplying a column by a number is just a line of code. Adding columns together, whatever you want to do. Filtering your data. I'm only interested in, rows that have this value and so on. Just really fast, really powerful.
That's
So
great.
tools like that make Python really good.
Yeah, no, I can imagine. There is a reason why everybody is gravitating towards Python.
Yeah.
Either you can do really good websites, MVC websites in Python. You could start off as your first programming language and it's easy enough, but it has these advanced features like this numerical library you're referring to.
Yeah.
That's good. And the good news is it's all free. If you want to get started, it's free to get started. And the libraries are probably also free. This is the beauty of this open source ecosystem. Okay,
Right.
that's all good, but what kind of jobs can I do? Because if I'm thinking, if someone is listening right now and they're thinking, okay, that sounds interesting, but complicated, and I don't want to commit to something where I may not see the return. So, what's the return here? What kind of jobs are available, and what kind of experience they need to have?
Yeah, yeah, it's a good question. Because data science is still relatively young, I think there are lots of job titles that might be relevant. Um, so most obviously things like data analyst, data scientist, but maybe also business analyst, maybe also data engineer, maybe also, quantitative researcher or something like that, statistician, applied statistician, machine learning engineer, right? So there are lots of different titles that are available. I think any boot camp that's worth its salt should at least prepare students for a data analyst role. And if you're tackling a data analyst role, probably you're looking at a healthy amount of data visualization, a healthy amount of interacting with databases using SQL, maybe some non-SQL databases as well too, if you have some unstructured data. But all that stuff I think is really within reach. It's a matter of learning the fundamentals of some of these tools, which I think you can do in 15 weeks. Um, if you're sort of dedicated to the study of these things, learning the fundamentals can go a long way, and you can do it pretty fast.
That's good to know. So, in other words, if I know databases, if I know my way around, basically I can write queries,
Yeah,
I'm comfortable with SQL databases. Let's say that I know SQL Server or Oracle or Postgres or MySQL, one of those, and I know a little bit about MongoDB or NoSQL, unstructured sort of databases
yeah,
which scale better, but I kind of know both. I'm not an expert, but I know enough. And then I learned Python, so just the ins and outs of just a few basic concepts, the syntax, the loops, and so on, the how to make a function and how to make something reusable, things like that. And then I look at the numerical libraries and some other very data science specific libraries and how to
yeah,
call them and what types of errors I get and so on and so forth. Now, I know that you would probably do a lot more in an actual um, Flatiron data science bootcamp,
hmm
but I think overall that you can get a few things in. So now I've graduated. I've done my 15 weeks. Can I actually get a job right now, or do I need to do further work, or do I need to work for free for a while, internships? How do I actually get a paid job?
yeah. So I certainly can't report that everybody who graduates from Flatiron has a job within a few weeks. That's not reality. But I can say that we do see graduates getting jobs, um, and usually it's probably on the order of 3 months, something like that, maybe 3 to 6 months. Sometimes faster. Sometimes students will get sort of a paid internship, or they'll get sort of temporary work. They'll have sort of contract jobs. That's certainly always possible. So I think it's realistic. We you know we have a Slack channel devoted to students getting jobs. And we're sort of constantly updating it and constantly remarking on it, like, hey, so and so got a job. That's really great. It's really sort of our North Star. So we're in the business of making sure students get jobs. We're not interested in you know uh, giving students a hard time or giving them lots of work to do. We're interested in getting them
Right.
jobs. So
Obviously, there is demand for data science. The reason we are even having this conversation and the reason you got the job as an instructor is because there are people that want to learn. And it is very, very, very relevant in these days where we have data everywhere, as you said, and we want to get some insights out of that. And some large companies definitely use it, but other small players probably could use it as well. That's why it's growing, because people are waking up to the reality that this could be useful or a competitive advantage. So they
Yeah.
don't want their competitors to have all the advantage. So it's going to grow. It has to grow. But as a young person, I know that there are jobs as software developers, just straight up full stack developers. I know there are jobs in infrastructure networking. There are jobs in database management,
Hmm.
even testing. Lots of jobs are out there. So, what kind of a person or what type of a person or a young person should pick data science over, let's say, full stack development? Or do you think you need to be a certain type of person who has a certain way of working or learning that would succeed in data science?
Yeah. So I think I would say, there obviously is quite a bit of overlap in the sort of skills required between data science and other types of software engineering roles or web development roles. I think data science especially caters to people who are just have a sort of natural curiosity about things. Um, they're interested in solving problems. Um, you know, Netflix works in part because it solved a problem. Uh, how many people watch a TV show and then sort of wonder, well, I finished that. What should I watch next? Um, Netflix has a really good way of answering that, right? Because they can say, well, here's all these other people that we know about. They watched that show that you just watched. They also watched all these other things, right? Probably you'd be interested in that too, right? And then so it's sort of easy for you to say, oh, well, yeah, I guess I'll give that a shot. And it's really effective, right? Because tastes are often, not as fine grained as the millions or thousands of movies and TV shows that exist. Right? It's like I have a taste for westerns, so if I liked that western, all these other people watch that western. They also watch this other western. I should give that a shot. So, if you have a sort of interest in sympathy for solving that kind of problem, working with that sort of issue,
Mm-hmm.
then I think data science is for you.
Okay, so good. And I'm imagining a situation where someone starts off as a developer. It's getting boring, not exciting anymore. They can say, let me try data science. I know Python already. I know databases. I don't know anything about data science, but I'll just go study on the side. The nights and weekends, I'll
Hmm.
find some resources, blogs, books, whatever, and I'll do something for 6 months, and then I'll try my luck. Maybe I'll get a job as a data scientist. And then, or somebody started as a data scientist, they just didn't like the work, and they would say, well, I know Python now, I know a little bit about databases, let me see if I can be a full stack developer. So you could switch between those, right?
Definitely, definitely. I think, again, I do think there's a fair bit of overlap there. Certainly, some of the lectures that data science students hear would be useful for full stack students and vice versa. So, yeah, I think once you've started opening your mind up to all the different tools that tech has to offer, then yeah, it shouldn't be a big deal to try to switch between the different levels.
What do you think are the best resources right now? So if someone doesn't have the money because it costs money to go to boot camps, what if they don't have the money right now, but they are interested and they want to pursue this? What are some free resources that they can use?
Yeah, one of my favorites is called codewars.com.
Okay.
I don't know if people know this, but it's basically it's just coding practice.
I thought
And
it was a first person shooter game.
yeah,
Looks
it's
like
not.
it, but no. Okay. So it's like lead code.
Yeah, it's sort of got this kind of Asian martial arts theme to it,
Ah.
but basically, um, it's a bunch of problems like write a function that does blah blah blah.
Mm.
And you can do this in just about any language that you can think of. I
Okay.
forget how many languages are supported, but it's, I think it's about 50 or something at this point.
Mm-hmm.
Um, so you can click on Python, you can click on R, you can click on, other data science languages or something else. You could click on C if you want to get deeper to the machine, as it were.
Mm-hmm.
Um, Lots of cool problems. You can just sort of work on building up your understanding of syntax, and it'll show you if you don't get it right. It'll show you what sort of problems you're getting. It'll print out error messages for you. So really useful, really nice way to sort of level up your coding ability. Um, I think there are also lots of um, ebooks and things online about some resources like Python. Stack Overflow, probably everybody says this, but Stack Overflow is a really nice resource.
Yep.
Lots of people post questions about, hey, I'm getting this sort of error, or why is it that this seems to work and this thing doesn't? And lots of smart people answer. You know,
Mm-hmm.
uh, Lots of really good resources there too. So, I think if somebody were really interested in data science and really was really starting from scratch,
Mm-hmm.
um, you could really Google data science 101 or something like that, and
Right.
you would find some good resources. There's just so much out there on the web right now. I think it's pretty easy to get started.
Yeah, I can imagine. And one of the best ways of people switching careers or moving up or having a kind of a sideways transition is to find perhaps something else that happening in your own company right now. If you're working for a large corporation and you're doing QA, which is
Yeah,
fun, but you want to do something more exciting. Maybe you want to go to data science, do some research. Maybe there is a data science department, and you will
yeah,
have. I mean, those people who already are working there, they have an easier time getting in. And
absolutely.
a lot of
Yeah,
times you may not be able to get the job that you really want, but you could shadow people, you could make friends there, you could start having lunches or coffee breaks over there, and you can pick up things, and they may be able to refer you to another company where they are hiring, or
yeah,
maybe just let you work on something and put something on the resume, because I think that would be the most important thing. In general software development, this is key. You need lots of projects in your resume so that not only that it shows that you have done some work, it shows that
mm,
you have finished projects, but it also shows that you you can handle it. And so the problem with data science is it seems to be that you need big data. And if you're if you're in high school, you don't have big data, right? You're
mhm.
not Procter and Gamble that it needs to sell to consumers. So that would be the problem. I think it would not necessarily be super easy to get working on it and actually produce and show amazing results if unless you're working in that kind of environment. And I'm assuming, I don't really know, but I'm assuming there might be some open source data sets or something that people can just use to hone their skills a little bit.
Yeah, yeah. There are some good projects that I've seen that were done on small data sets.
Mm-hmm.
It's still possible if the data sets are sort of interesting enough.
Definitely.
So that's definitely a possibility. There are also lots of cloud services that people can utilize
Ah.
to handle big data. So maybe I can't hold this whole data set on my
Mm.
machine, but I can tap into virtual machines
Mm.
courtesy of Google or Amazon or something.
Do you think this is really tied to machine learning? Because I hear a lot about this, where you can show a picture to a program and it can actually show you similar pictures because you have trained it using artificial intelligence, neural networks, and all of that good stuff, where
Yep.
actually it can see patterns. Once it knows what you're looking for, once you train it, then it can see patterns. Is that, would you call that data science? Or,
Oh yeah, yeah. I'd say that's a branch of it too. because ultimately it's really just another type of model. A neural network it's a model, really. It's just a really fancy sort of model, right?
Mm-hmm.
I've introduced the machine to thousands of images, maybe millions of images. There are networks like this around. And if I feed it labels for the different images, I say, I just gave you an image of a cat, right? That's a cat. An image of a dog. Here's 10,000 more images of cats. Here's 10,000 more images of dogs, and airplanes and houses and whatever else.
Mm-hmm.
Well, there are lots of ways that you could depict a cat, right? But if you have a nice diversity of cats, some of them are standing up, some of them are lying down, some of them are awake, some of them are asleep, some of them are black, some of them are white, et cetera, right? Well, then what the computer is going to be learning to figure out what constitutes a cat is not, it's not just some particular arrangement of pixels.
Right.
It's some very complicated pattern, right?
Yeah.
Well, the pixels might look sort of like that, or maybe they're more like this,
Mm-hmm.
And if pixels of the image are basically themselves the columns of data that I'm building my model on, right? Then it's the same principles apply. Pretty cool.
Okay, that sounds good. So we learned today about data science and how Greg Damico, you went in there and then you just nailed it. You you succeeded in not only learning but also teaching data science. Just a new exciting field for people who are looking to become software developers or looking to get into technology. And for some people, this will be right in the sweet spot, right? For some other people, it may not be. So it's something to explore. And I'm so excited that we finally got the chance to talk about data science and let people know that there are other things that they can do with their careers. So it's been great talking to you, Greg. Is there any way people can get in touch with you?
Yeah, you can certainly find me on LinkedIn. If you look for Greg Damico at Flatiron, I'm sure you'd find me on LinkedIn. I'm also GADAMICO on GitHub. So happy to have people reach out to me.
Yeah, that was great. So on your screen right now, you can see the link for this episode. It's episode 91, mentoringdevelopers.com/episode 91. You can also send me emails at us@mentoringdevelopers.com. If you go to that link, you will see the show notes and links. Some of the links that Greg mentioned will be in there as well. So you'd be able to find it. You don't have to memorize it as you're watching this. Get in touch with him. Get in touch with me. The email is on the screen. And ask questions. It's good to ask questions. Greg is there to help you. I'm here to help you. And my job will be to learn more from Greg if I get a chance and learn more from elsewhere, because I really am curious about data science. It's fascinating. And I have to say I'm a beginner when it comes to data science. So Greg, it was great talking to you. Hopefully we'll see you again soon.
All right, thanks so much. Appreciate it.
Bye everyone.
For show notes and transcripts, visit us at mentoringdevelopers.com.